Alrighty, so again, these examples, right, straight out of your book, and work them. Look at my examples. Look at what I've done with them. If you still don't understand it after I've gone through it, make sure that you ask questions about it. So, alrighty, taking a look here. Simplifying expressions. What is the simplified form of each expression? In this case, we're going to use distributive property. So we can see here that they've distributed the 3, so 3 times the x, 3 times the 8. So that becomes 3x plus 24. Nothing else I can really do with that. I can't combine those into like, 27x something. That's just not the case because they're not like terms. Here we're going to distribute the negative 7. So, whoops, there we go. The negative 7. So negative 7 times 5 is negative 35. Negative 7 times, now remember this is technically the same as, plus negative 4. So you're really multiplying times that negative. So negative 7 times negative 4 is a positive 28. That's why that's positive there. Make sure you get that. Something you should have, I'm sure, covered last year. Alrighty. The got it's on the next page. Here we go. Simplified form of each expression. Again, you can take a quick look at the answers. If you got it, you got it. You can fast forward to the next example. Otherwise, here we're going to distribute the 5 to the x and the 5 to the 7. So that becomes 5x plus 35 because 7 times 5 is 35. Here we're going to distribute 12 times 3. That's our 36. Notice I'm going over here to the right. And 12 times negative 1/6 is negative 2. Right, so 1/6 of 12 is 2, we know that. And don't forget the t there. Here we're going to distribute 3 times 0.4, that's 1.2. And then we're going to have 3 times 1.1c, which is 3.3c. And then finally, now you might be tempted to call this negative y, but it really means the opposite of y. The opposite of y times times 2 rather is negative 2, and don't forget y times y is y squared. And then the opposite of y times negative 1 becomes a positive 1y. Remember that is technically 1y. There's like a secret hidden ninja 1 there or something. Something else you might want to do is to be able to rewrite fraction expressions, and distributive property does that for us, oddly enough. In this case, we can see we have it's divided by 5. If you remember, dividing by 5, so it doesn't matter what number is like, right? 10, right, divided by 5 is the same as 10 over 5, right? So that's the reason that's going to work out for us. So in here, pull out that multiplying by 1/5, right? So multiplying out that 1/5, turning division by 5 into multiplication by 1/5. That's what I'm trying to spit out. And then you can go ahead and just distribute that 1/5. So 1/5 times 7 is 7/5. That's our x. 1/5 times 2 is 2/5. Pretty much straightforward. We're doing something very similar here. We're going to take out, first off, this becomes 1/3, right, times 4x minus 16. So that becomes 4/3. And we can see I have the answers up over here. It becomes 4/3 minus 16/3 once you distribute that 1/3. This one is going to become 1/6 times, times 11 plus 3x. So and that becomes, we can see right here, 11/6 plus 1/2 because 3/6 is 1/2 x. On here, this becomes 1/12 times 15 plus 6x. So don't forget to reduce, right? So this will be 15 over 12 plus 6 over 12, the x. Technically, the x goes with the top, by the way, in that case. 15/12 becomes 5/4. As we can see over here, from 5/4, and 6/12 becomes 1/2. And then finally, right here, we have 1/8 times 4 minus 2x. So this becomes 4/8 minus 2/8 x, which does obviously indeed reduce to 1/2 minus 1/4 x. Using the multiplication property of -1, what is the simplest form of this? In other words, you're distributing a -1. Remember, there's a secret -1 right there. So in this case, it just becomes -2y plus 3x because negative times negative is positive. Or in this case, you could flip them around, right? It could become 3x minus 2y, but right there is what we're looking for. Simplified form for each of these, distributing a -1 in each case. So here we're going to have negative a, or the opposite of a, minus 5. Here we're going to have a negative times negative is positive, so it's positive x, minus 31. Here we're going to have negative 4x. Again, negative times negative is positive, so plus 12. And here we're going to have negative 6m, and then negative times negative is positive, so plus 9n. And that's it. Now, we did mention before that one of the greatest things about distributed properties, it really kind of helps with mental math. Maybe you don't even realize you're distributing, things like that. Deli sandwiches cost $4.95 each. What is the total cost of 8 sandwiches? Use mental math. So, you might think, oh, I'm going to take off a nickel per each sandwich times 8. So 5 times 8 is 40, right? And then a nickel off each one is going to give us 40 cents, so $39.60. That's really what's occurred here. So notice 5 minus 0.05, that's the same as $4.95. 8 times 5, 40, you can do in your head. 8 times 5, 40, you can do in your head. And that's an easy subtraction. That's assuming there's no tax, which there isn't, so unless it's heated up for you, right? All right, a little mental math on this one. So Julia commutes to work on the train 4 times a week. Round trip ticket is $7.25. What's her cost? So if you have 4 times 7.25, that's the same as 4 times 7 plus 0.25. 4 times 7, that's 28. 4 times 0.25, that's 1. So 29 is what we're looking at. That's our mental math done there. And I could have just talked through it, but I thought maybe you'd appreciate it if I wrote it out for you instead. Okay, so combined like terms really means adding terms that are like, right? So 8x squared plus 2x squared is the same as 10x squared. And here they're kind of using distributed property to prove that to you by pulling out the 8 and the 2, right? Sort of undistributing them and then combining them. Now here, what I'm going to do on this next one is the way I like to do this. I'm going to write it out first. We have 5x minus 3 minus 3x plus 6y plus 4. I'm going to go ahead and make some comments about the like terms here. 5x and negative 3x are like terms. Notice the sign in front goes with it. Negative 3 and 4 are like terms. There's nobody like the 6y. Sorry, it's kind of lonesome. Now we can use our commutative and associative property to move everything around, right? And reassociate. So in other words, what I'm saying is the 5x minus the 3x. So I can say 5x minus 3x. I can also say minus 3 plus 4. Notice I commuted them around. And bring along the plus 6y for the fun of it. Combine like terms, we're going to have 5x minus 3x is 2x. And then we have minus 3 plus 4 is plus 1, and bring along that 6y for the fun of it. Now if you were to put this in standard form, it would be 2x plus 6y plus 1 would be the simplified form. Alrighty, so simplified form of each expression here. So I have 3y minus, technically remember that's 1y, right? So that becomes 2y's. That's A. B, we have negative 7mn to the fourth minus 5mn to the fourth. Notice, double check here, right? Same variable, same power, mn4, mn4. Well, so we have negative 7 rather, minus 5, just works just like integers. So negative 12, then mn to the fourth is what we get for that one. And then this last one here, before I even start, go ahead and make sure that they are like terms, right? So I've got y cubed z, y, ooh, look at that, yz cubed, y cubed z. This middle one is not a like term. So if I rewrite that using my commutative property of addition, I'm going to have 7y cubed z plus 1y cubed z minus 6yz cubed. Now I can see I've got my like terms next to each other. So we're going to have 7 plus 1 is 8 y cubed z minus 6yz cubed. And again, these have the same variable but not the same power, so you're done. You can't do any more combining right here. And then the last one, can you simplify that statement any further? And again, the answer is no, because there are no like terms to combine, so you're done. You can't put these x's and stuff like that together. So.